Good evening, friends. Welcome to Eastern Academy. And we are discussing about embedded programming as a part of embedded system programming. And today is session 7 of embedded programming. And in this session, we are going to discuss about how to control dot matrix display. Okay, this is almost like a keypad. Both are same. That's why I discussed about keypad in the last session. And some of you have asked about doubts about keypad. I'll just discuss about a keypad first, and then we move on to the dot matrix. Okay. Don't hurry up. Let us make to understand keypad. Both are very important. These two are a big challenge for your programming skill. If you could able to discuss these two, that is dot matrix and keypad. If you could write your own functions and try to understand that very well, then you will be able to make good programming skill. Then things will become very easy. As I mentioned to you, there are 5 things that are very important. As I mentioned to you, everything should be very clear. Okay, so what are the 5 things which we understand? These 5 are the most critical ones. Where you have a microcontroller. You have a microcontroller. Then you have a ports. You have ports. You have ports. Now, there can be n number of ports. There can be a number of ports. And you connect the devices directly to port, and by controlling character star out is equal to some address star out data. See that you do this, you control directly the device. So the direct connection between microcontroller and devices. Okay, that's the first thing you have to understand. What are the devices we have discussed so far? We have discussed about 4 devices. One of them is LED, single LED or multiple LED. One LED, okay, per pin. If you want 2 LEDs, connect them 2 LEDs. But you need to put a resistor to current limit. You need to find the value based on the voltage applied here, the type of LED you are using. If you use blue, then the voltage across is 4 volt. If it is green, the voltage is 2 volts. So that vary. Same way, you may be having a microcontroller of 5 volt or 3.3 volt. So which microcontroller are you using, what LED you are using, based on that you have to calculate the resistor. Okay, that next week when we start our electrical session, you will understand more about that. Okay, so please understand this very important concept. That is, you have a microcontroller, you connect LED. That's the first one. Second one is switch. And third one is 7 segment. In 7 segment, single, dual, or quad, or octal. You can have 8 displays also. You should know how to connect them. Then we discussed about keypad. That means your switches are connected in matrix. So this is very simple. You just out. This is very simple. You in. This is just out. Understand? This is out. This is in. This is out. So they are simple. They are only one operation. But the keypad is the one which is slightly complex. What is the complexity? that complexity is we have, for example, a port with 4 pins, only 4 pins. Okay, these 4 pins are going to control 4 rows. Please understand. Then there are 4 pins here which are connected to the 4 columns. We call this as a C0, C1, C2, C3. So C0, you connect this wire. C1, you connect this wire. C2, you connect this wire. C3, you connect this wire. Am I right? But the problem is these 4 columns are common for switch 1. Let us assume the switch 1 here. Switch 1, switch 2, switch 3, switch 4. Understand? Now, if you press any of the switches, you connect this row versus column. How do you know that which one I press? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 switches. Am I right? When you have 16 switches here, how do you know? Now I draw it in a very a different fashion. Then you will know that. Let us draw in a very big way. Otherwise, you have always the complexity of this. 4. We call them C0, C1, C2, C3, because the same concept is going to be on the this also. Dot matrix, I've explained this. Okay, once again. And a lot of people are having a doubt on this keypad. That's why I've explained now. Now you have switches like this. So you have 16 switches. This is what we discussed in the last class. And this is since most of them have a doubt on this, I'm explaining this. Understood now. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Understand now. Now this is row 0, row 1, row 2, row 3. For example, you connect all of them as 0 volt. All this rows are 0 volt. Assuming all the rows are connected to 0 volt. The columns, I told you that you need to connect a pull-up. You need to connect a pull-up. You cannot leave them. Oh, sorry, pull down. Is it pull up or pull down? Let's say we make a pull down. So I have a microcontroller which a port 4 pins. I read C0, C1, C2. Let me draw it here itself, big way. I have a microcontroller and I have row 0, row 1, row 2, row 3. C0, C1, C2, C3. Now all the rows are outputs. Understand? These 4 are output and these 4 are input. Let us assume that you have not pressed any switch. If you have not pressed any switch, if you read all of them, I'll get always 0, 0, 0 because there's a pull down. that will be 0. Understand? Now, this is a trick here. What you have to, software have to do is, in a for loop, first you have to make row as a 1. You make this as a 1. So this whole row will become 5 volt. Or this will be 0 volt. This will be 0 volt. This will be 0 volt. Now you have to read the column. Please understand, you output 1 on row 0. Then read the column. If the columns are 0, 0, 0, it means that no switch is pressed. For example, if you press this switch, understand, if you press the switch, now this is 5 volt and this is connected. So this becomes 5 volt. I get 1 here. So your software should be intelligent enough. Oh, I give row 1 and I get column 1. Now button 1 is pressed. Same way, if I get 2 here, if I get this is 5 volt, the problem is, please understand, all the others are 0 volt. Even if you press any other switches, I will not get 5 volt. I will get 5 volt only if you press the top row switches, because I have given here 5 volt. Now what I'm going to do, I make the next row as 1. This is 0. So this wire becomes 5 volt. This becomes 0 volt. Now if you press the second row of buttons, then only you will get 5 volt. So this has to be like this. I'll tell you the thing. What you have to do is out row 1, row 0, read. Out row 1, read. Out row 2, read. Out row 3, read. So you should know that on which read you get the number other than 0. If all the read you get 0, that means that no button is pressed. Understood? If I press this button, in this row I will get the voltage. When this is 5 volt, if I press this button, that button is pressed. You understand now? That is, this is not 1 out, 1 read. This is called actually, this whole algorithm is called keypad scanning. If you listen to this any number of times, you will not get it. You go and see the last class video of this one. What do you call it? Keypad video. And I've given this one also, how to connect and how to do that. I've also connected 8 LEDs. Try to understand that program and start writing your own program. Then only you don't use the program. You should write, you should stop it, you should not draw it once again, you should be able to understand. So this is for you, this is a skill. So this is what all about keypad. This is you out, read. Out, read. So you have to do that once again. So you cannot do it at one shot. Now let us get into the dot matrix. What is dot matrix? If you have a doubt on the keypad, let me know. I'll create one more video and send it to you. Okay. Otherwise, if we start explaining more here, the schedule goes off. Okay. Now, what is dot matrix? Now let's say take keypad. Now you have a LED. Am I right? You have a LED. Normally, how do you connect the LED with the microcontroller? It's very simple. How do you connect? You put a resistor and you connect it to ground. If you make this pin as a 5 volt, let's say this is 330 volt ohm, and this is a red LED, 2 volts, 3 volts, approximately, because they so 3.3, but they put approximately 3 volts. So you get 2 volts. Now see here, in this method, if you make here 5 volt, light will glow, LED will glow. If you give 0 volt, LED become off. All right, this is a very simple. That's where we started. But now we have another concept. What we do here is we connect that to the another pin. We connect to the another pin. See here. If we make this pin as a 5 volt, understand? If we make this pin as a 5 volt, these are 2 ports pins. Now, if you make this pin as a 5 volt, if you give here 0 volt or 5 volt, anything you give it, the LED will not glow. Because in both the cases, this LED become reverse bias. Because the cathode and anode voltage never goes above 0.7. So it's above 2 volts. So it will not glow. Do you understand that? So we connect. Let us see this in an example. So let us see this in an example, then you will understand. That's a trick. As we discuss everything, we'll see from the beginning, not at the end. From the beginning. If I give you the final picture, then you seems to be convinced. But let us start from beginning what I'm doing. If you don't understand this, you will not be able to understand the other one. Okay. Now we have a board. Okay. I take port F and port K. Am I right? So I take from port K, I take one LED. See here, I take one LED. I take one LED and connect here. Let me make this one as a top way because I don't see I can connect this LEDs better way. Or I can make this one as a rotator. So I can put it in the top, it'll be very easy. Let me rotate it.
Sir, your screen is not visible, sir.
Oh, thank you. Thank you. Let me share it. Oh, God. Thank you. Oh, this is correct. Sometimes we talk is correct because I don't see even the chat. Okay, let me do this. This one. Oh, you see that? Now it's okay?
Yes, sir. Now it is.
Rotate 180. See, I rotated the. I think it's easy for me to draw it now. Now what I do here is, I connect a LED. This LED is there. See, this is what exactly we draw a circuit diagram. People call it as a hardware. Na? This is what exactly hardware. I'll tell you some more thing later. The hardware. So this is, I connect this wire, port F, to the anode. Done. Now I add a resistor and I connect to the port K. 0th pin. Both are connected to 0th pin. Understand? If I connect it to ground, let us assume that I remove this. I remove this. I connect it to ground. I just connected to ground. Now port F, what is the address? Let me write the program. See. Can start DIR, DRF, volatile, can start out F. 2 ports. I'm going to use only out. Now I say DIF is equal to 0x. I don't remember. Sorry. 1 minute. Very, very sorry. I have a very poor memory. think 31, 30. Out F is equal to 0x31. The address. This is very important. You should know the addresses. Okay. This addresses has to be known by you very clearly. And as I already explained to you that so many times, this is very simple. Port F is here, the document. Port F 31 is out, and direction is 30. That's correct. Fortunately, I'm right. Direction is 30. Now, what I'm going to do here, diref is equal to 0x01, making this output port. And out F is equal to 0x0. I'm making it on LED. So if I make this one, run the program. Oh, what is it? Why LED is not glowing? Oh, sorry. You know the mistake. I forgot to put star here. I changed the address, but I didn't change the data. So you should know that what is the mistake. Yeah, now light is on. It is a very simple. You make this one as a 0 out, then LED is going to be off. This everybody knows, very simple principle. But what I'm going to do now is I'm going to disconnect this and I'm going to connect this pin to the other port. You understand? Now let us run the same program. Let us see one here. I don't change any program now. I run the program. See, the light is not on. This is not affected. Now this has to be made 0. So what we have to do here is, I have to make diref dir k. Same way, out k. See, in a keypad, we have one output port, one input port. Here, 2 output ports. That's it. Now I say dir k is equal to 0x108. Am I right? Am I right? 107. Out k is equal to 0x108. Now star diref is equal to, I'm making this a bit 1 output port, output pin. Now I say star out f is equal to out k, sorry, all k. I did a mistake. Please understand, this is very, very simple numbering, but it's only naming. If you say I'm confusing, I will not touch this, then you don't get into the level of embedded what you like. I'm making this bit as 0 now. See that? I'm making this bit as a 0. I make this as a 1. So now this is 5 volt and this is 0 volt. So let us stop it and run it back.
Sir?
Yeah.
Sir, what exactly means 0x01, sir?
Yeah, 01 is 8 bits. 01, 00001.
No, sir. It is in. We are assuming that it is an input or output, sir. What is that?
Output. Or both are output.
Okay.
Both are output. Okay. That's why I make it as output. Okay. The direction is output. Okay. Anything mistake here? Anywhere? What is a mistake here?
Sir, in the definition, we have to declare it as.
Oh, thank you. Yeah, see that it's the age problem. Okay, now we run it. Yeah, now LED is on. See that? Because I make this pin A8 as a ground. That's why it's making. See that? I don't change the anode pin. I change only the cathode pin. See that? See, normally you have been told that you have control only anode. But here, we control both anode and cathode. See that? I control anode and cathode. That's a trick here. Why it is used? See, please understand. I control, see, let me go back to the board, then you will understand. But I want to show you now, I've shown you. Okay, I'll show you next to 4 LEDs. Then now it's only 1 LED. Okay, then we will show 4 LEDs, we will know that. So let's take every stage, stage by stage, we will proceed and go, not an hurry. Because this is very important. The trick here is typically you control only anode. Am I right? You control only anode. You don't control the cathode because cathode is connected to ground. But in this case, we control the cathode also. Why? I'll tell you now. I'll tell you a reason now. The trick is, now I have same way. I have what I've drawn in the this one. Am I right? Keypad. Now here is a LED. Here is a LED. Instead of switch, we change it to LEDs. Instead of switch, we change it to LEDs. Right now. Now, if we give here 0, 1 or 1, 1, which LEDs will glow? So let me change this direction, then it will be easy for us. Sorry. Let me change, sorry, I'll change the direction of LED. See now, if I give here 1, 1, which LED will glow? You have LED 1, 2, 3, 4. Let us say 0, 1. If I give 0, 1, which LED will glow? You cannot say, because the cathode pin, okay, let's say we have a resistor here. We have a resistor here. The cathode pin is not connected. Let us assume that I make this one as a ground. I make this one as a 5 volt. Now you know that if I give a 0 here, this will not glow. 1 and 3 will not glow. But now see, I give on 1 here, 5 volt. Now which has to glow? Either 4 or 2. Which will glow? The cathode of 2 is connected to ground. Now this is forward bias. So 2 will glow and 4 will not glow. If I connect this one as a ground and this one as a 5 volt, now this will glow. This will not glow. Okay. So at a time, you have to make only one row on, because otherwise the same data will be duplicated. That is not right. So now I connect the same thing on our board and show you that. Okay. Now I connect the same thing on the board. I'll show you that what's happening. Please look at that diagram. It'll be very, very interesting. So now let us make a 4 LEDs. Okay, I'll remove the resistor. Oh, sorry, stop. Okay, now I connect 4 LEDs. 1, 2, 3, and 4. Okay, 4 of them are there now. So now look at them. There are 4 LEDs. Now I'll tell you how are we going to control it. If you understand that, you understand dot matrix. That's the only thing. There is no difference between 2 by 2 or 3 by 3 or 4 by 4. You better understand 2 by 2. Now what I have done is, this anode are connected to this. So what will I do here is, I make them as a change the direction. Okay, this LED resistors R1, I say rotate. (180). Sorry, 90. Am I right? Now this has become like this. I connected here. Now I make another one. I'll make one more resistor. R2. Just cut and paste. It is not. It's a nice one. It's actually you'll understand this better. Nice way. See this? Everything is practice. Just a practice in a minute you get it. Now I got one more also. Now I make one more LED, one more resistor, because there are four of them. Of course, in the simulation, even without resistor, things will work, but I don't want to make you to do that because it's simulation. So in simulation, that's not a this simulation. Sorry, not all the simulation. Here we are going to give a functionality, not electrical connection. We are giving a importance to functionality. Now there are four. Am I right? We connect here. Now what we have done is, see that I connected this pin to every anode. I connected to a resistor. As I'll start the diagram. Sorry. Yeah, this one. I'll change the video. See here. This video, we have seen it now. Am I right? We have seen two LEDs. We connected resistor in the anode. That's what I'm doing now. Now this resistor connected to anode. And this one, I connected to this. And this one, I connected to this. Now we connect A0 to this guy and A1 to this guy, as exactly we have connected here. Now this anode one, see here. We are connected to A8. And we connected this to D8. Same thing, whatever you see in the diagram. Okay, please understand. But this anode, and these two anodes are connected. Let's say you wanted to have avoid the confusion. You can this one go here. You can say this anode connections. See here, anode to anode connection. See, cathode to cathode, anode to anode. You've drawn the line here. This is the cathode connection only. Am I right? These things are cathode connection. So what happened? I do here is I change the color to blue. See, I change the color to blue. Okay, now this is blue colors. Okay, so that way I don't have to do the thing. Now it is done. Am I right? No, I don't need this. This screen is, let me not have it. Now, what I'm going to do now is same thing. There's no change here. You see here out 0, 1 and 0, 1. And out of out, we don't worry about this. Let me write these two lines bottom. Generally, we have to, we'll understand that. because we're going to change the two lines. Now this port is K, and the F, this port is K. Now I'm going to make these two ports. I'm going to control it. I'm not worried about now. These are all the first things are all initialization. I'm not worried about now. I'm worried about only these two. Okay. Now let us see here. Out K, I01. I make 03. Let's pick 03. And these are also 03. That means all of them are 5 volt. If you run them, what happens now? The LED will not glow. The LED will not glow because both are 5 volt. Now out K, I make a 0, 1, 0. See that? I make 2. I make 2. That is 1, 0. I make this one as 0. That is A8 as 0. So this LED and this one is 1. So this LED should glow. Not glowing. Anybody can tell me any problem? Oh, out F, I did a mistake. Sorry. I put out K. So, see that? I was showing you this out K, but I make it as out F. Sorry. These are all small confusion will happen. You have to manage. You should be able to debug it. See, this one is glowing because now this one is 0 volt. Okay. And this one is 5 volt. Whereas this one is 1 minute. Why this is not glowing? Let's make 1 minute. 1 minute. I make everything as 0. Oh, 40 of direction 3. Yeah, but that does not affect actually if I'm right. Let us see the thing. Let me see. Now I make everything 0. All LED should not glow. Okay. Now I make only port F as 1. 1. 1 means that LED should glow. See, both are glowing. You know why both are glowing? In K, both the things are ground. So this guy is 1. Now this one is 1. And both the LEDs are glowing. Now we see that I make port K as 20. Port K as 20. That means that 10 is 2. So that means that this is going to glow. This will not glow. Now you see that. This should glow. Only this has to glow. Then see that what I'm doing now. See here, only this is glowing. Now I give a delay for I make 1 by 1 on for long I. Let us say I define the variable here. Volatile long I. I give an I, small variable. Now I say for I is equal to 0, I less than some big number. Then you can be able to see that very clearly. I plus plus. This is a delay. After a delay, I'm going to give one more value. You understand now? Now what I'm going to do is I'm going to make the top one as on. Okay, the bottom one is on, now top one. That means that I make this one as a 1. Try to understand that. This anyhow, this I'll share the code at the end of it. Then you'll be able to understand that. Just you click and watch it. Enough, you will get it. Now what happened? I want to make this one as on. That means that this should be, F should be 20, and this should be this one, the bottom one, that is 1. Now, then what I'm going to do, I'm going to make once again a copy. I'll make 1 by 1. No, I want to show you a very important thing. It looks to be very simple, but you'll be very surprised. 2, 2. See here, 2, 1, 1, 1, 1, 2, 2, 2. There are 4 combinations. Am I right? Now I stop it. Now let us see what is happening. I give a big number. That will be very, so it will start now. This is itself enough. See here. Let's make a big delay. Then you'll be able to see that. Understand. See, this is a very, very important thing. At a time, only one LED is going to be on. So let's stop here. Let me do one thing here. Let me do 1, 1. Sorry. 2, 1. This is port K. This one. This port is 2, 1, 1, 1. 2, 2, 1, 2. Let me make it this way. Then you'll understand. This is 5 volt and 0 volt only. There's nothing more than that. See here. So you know, you are watching the code now. Please understand. You have any doubt on the code. Now understand the code. What I'm doing now is 2, 1, 1, 1, 2, 2. I'll draw it on the thing. What is happening? That is. let me go back to the board. Then you will understand what I'm drawing. Now you see here, I make this is bit 0. This is bit 1. This is bit 0, bit 1. And this is port F. This is port K. I make initially 2, 2. Am I right? That's what we have written now. So this has to be on now. I want this light to be on. So this has to be 1. That is 5 volt. Understand this very clear. This has to be 5 volt. This has to be 0 volt. And this is 5 volt and this is 5 volt. All of them are 5 volt. Sorry, this is 0 volt. Sorry. I want to make only this one is on. So what is happening now? Since this is 0 volt and this is 5 volt, and this light goes here, this is on. Now I make later, I want to make this one as on. Then I keep the 0 volt, but I keep this one as a 0 volt, this one 5 volt. So this LED is on. Then I make this as a 5 volt and this as 0 volt. That time, if I give here 5 volt and 0 volt, and this is 5 volt, this is going to be on. Then I want to make this one as on. I make this is 0 volt and this is 5 volt. This combination, you try to learn it. Okay, I don't want to see. If I explain too much, sometime you may not be able to do that. But please keep the diagram. The video is with you. Understand the diagram and draw it. Once again, you will understand that. Now let us go there. See, what is the trick here is, this is what I'm going to explain you is not a normal principle. This is the way all your LCD TV, LED TV, everything is working. The whole moving display, all the displays are working this way. That's why I'm giving you the, I'm taking slightly more time to explain this. Now, if I run the code, one by one all on, am I right? Because of the numbers. Now let me do one thing. Let me put this in a loop, while loop. While one. Am I right? I'm putting them in the while loop. I did the code now, then I've written everything in a while loop. So what will happen since I put while one? That's why I'm repeatedly telling you that knowledge of C programming is very important. Sorry, skill. C programming skill is very important to do this, understand these things. Today, electronics is equal to C programming. I can do C. These things, if you start doing wiring, it will take very long time. So now you see that if you run this program, let me make this delay small. Then you will be very easy to do that. Make it a 2. Now I run it. See that now what is happening. Am I right? The LEDs are one by one glowing. Now reducing the time to 1 lakh. It's very fast. Now I reduce it to 50,000. Yeah, correct. Exactly. Yeah, that's it. That's why decoration of lights are like this only. All the lights. Now you see what is happening. I reduce the time to what happened? Oh, I didn't run it. Sorry. I reduced it to 50,000. Now you see how fast it is running. See, it is so fast. Now I reduce it to 10,000. See that? I'm reducing it to 10,000. Now what's happening? See, it is real fast. You don't see the speed. Now I change it to 1,000. Now I change it to 1,000 now. See that? See, you see only, you don't see even the, but actually what is happening? Please understand what is happening actually. Actually, at a time, one light is on. At a time, only one light is on. Please, you watch the code. See, this is a confusion. That's why let me go and think. I call this as a delay. I call this as a delay. I don't want to make things boring. That's why I just delay. Please understand the principle very clearly. Now go here. I'll put here hash define delay as 20,000, 2 lakhs. Now I stop it. I run it. No. Yeah. I using a delay. Delay will be replaced. If tomorrow, next time onwards, I replace this number is enough. I do not have to replace everywhere. It gets replaced. See that? Now it is very slow. But see here, when I reduce the number to 1 lakh, that is fast. When I reduce the number to 50,000, still fast. Give it to 10,000, 20,000. Yeah, you see that it's going fast. Now, when I reduce it to 10,000, yeah, it's going, but you don't, you see only like a blinking. If you go closer, you see the blinking. Am I right? Now, if we reduce it to 1,000, see, you don't see even the blinking. If you reduce it to 100, oh, here no units. I'm just, it's the for loop takes, that depends on the processor. This processor takes some time. If you do the same thing, Arduino, you know, that guy will be using different time. Yeah, this will work, right? It doesn't matter. Somebody said, why I'm putting it here? This is my way of working. I don't use that while loop. You put the same code, remove the while. While only, same thing, while only. Remove the while one. Okay. And copy this code. Copy this code. Sorry. See, the trick is that if I do like this, then it's like Arduino programming. That generally I wanted to avoid that. I'm using Arduino board and Arduino IDE, but I'm trying to use the normal program. That's why I write that. So normally in your normal programming, in your main program, nobody gives you this wide loop and everything. There you have only a main. So now I make setup as a main. That's why I'm doing this one. You can write this also. This will work now. See that. I make this number as a. It's also same. What is this? Oh, I've not see here. Sorry. That's now these things are becoming local variables. So I have to do that. No problem. That's fine. Solve 1 minute. We solve the problem here. Am I right? Now I ran it. If you put it on here, I have to do this much, but it doesn't matter. It takes about a minute for you. You can do that. So this is also a good method. There's nothing wrong. I shown you both the methods of coding. See, it is quite slow because I give a big delay. You change the number to 1 lakh, then it will be very fast. You change it to 10,000, it will be much faster. If you change it to 1,000, you will never see the blink. The timing is so fast. You don't see that. This is called your eyes. Yeah. This code will work on any microcontroller. Only thing is you have to change the port address. That's all. This address, that's why I'm writing a code. This address need to be changed. This address is, you have to, if it's ARM means how to write this direction, you should learn only that. On this code will be fine. This code is common everywhere. Also, this delay will be that will be faster in ARM. You have to change, you have to find out the right number for that. That we are going to see that. Next week onwards, we're going to see that timer programming. There you will know that how to write an independent code. How to write an independent code of all microprocessors. There are some methods, sir. I'll explain to you the methods next week. How do you write this as an independent code? They are called HAL. That is called hardware abstraction layer. your code will work irrespective of any hardware. Okay, let us try to understand this code. Okay, let me make this one as a small. This I'll share this one to you. That's better. I'll save this file. Two x2 dot matrix. Okay. I make 2x2. Must understand that. I'll let me share this. Save it. Now let us. I don't want to keep the thing afterwards. Okay, so I have shared it now. So you might have got it now. Okay, have a thing. So the code. Oh God, that's a problem. This guy. The connection, if you move them now, this guy will. There's some small bugs. That's good. Outside a little bit. Okay, so let me leave this screen as such for you. I'll stop the recording.